2105. 2105. We'll start off with a comparison to 2013. They're somewhat similar. 2105 has flatter performance over a slightly reduced bandwidth. 2105 I've taken down to the limit. The lower frequency limit is 100 megahertz. The upper frequency limit is about five. I think we squeezed out 5.5 gigahertz. Certainly 5 gigahertz. So it's a little bit more narrowband than the 2013, but it's way flatter and equally as popular because a lot of customers just love that broadband flat performance with one match. They don't have to worry about anything except plopping it down and using it in multiple designs. It's got a better noise figure too. Slightly lower IP3, 4 to 5 dB lower IP3. Much better noise figure. Not much better noise figure. Half a dB to a dB better noise figure, depending on where you're at. So 2013 and 2105, you look at all the broadband applications and you often decide which one's better based on the specs. Twenty plus or minus 1 dB all the way to 5 gigahertz. So it's flat. The only wart per se is that, again, to get the broadband performance, to get the nice numbers and flat gain overall, that broadband frequency, standard eval board is like 400 to 4 gig standard eval board. What you give away is just like with 2013. You get some return losses in between that are return loss less than 10 dB in between, maybe 8 something in between. In other words, you give away the down in the dirt return loss for performance otherwise, and it's worth it. It's worth it. No, hardly anybody complains. Hardly anybody complains. And if you have a narrowband application, a more narrowband application, you can optimize return loss with relatively simple matching. So it gives you flexibility. It's a good design practice in my mind to say, hey, the return loss is going to get a little below 10, but everything else is going to look beautiful. We wondered about that in the beginning. Given the industry standard where these broadband game blocks had return losses of 18 to 20 dB, right? What are people going to say if you're flirting with 10 dB? Hardly anybody complained. And you can buy back some performance that way, because that's what you did.
Any of you guys call me Francis, and I'll kill you.
Well, you know what? 2105, I'd have to look for the specific numbers, but I do remember one instance where 2105, a customer in Israel had the 2105 in there, and their EVM was taking too long to settle at turn on. Okay, so I did some comparisons, and I think they ended up using the 2013, and they were happy with it. So it wasn't a huge difference, but in that instance, it made enough of a difference where they ended up going with the other device. So you will encounter trade-offs like that, some of which you're relatively unaware of till they show up. And then the good thing about Gorilla RF is we have a myriad of options I can pick and choose, and hey, try this, try that, try this, try that, until we find something that works. We just had one. You were talking to me yesterday. We just had a switching time issue. Somebody needed better than 50 nanoseconds, which is hard to measure in the first place because you have ringing on your function generator. But I borrowed Dan's function generator, got reduced ringing, and ran the GRF2105 and got a switching time less than or equal to 30 nanoseconds. So we just updated the data sheet. So sometimes it's really important. They need it to be really fast. And I have to remember which of my devices are quick enough to do it. It's hard to get a switching time that low, that fast, but you know. I think it's on the order of hundreds of nanoseconds. 1200 nanoseconds on, 400 nanoseconds off. So 2105 has 1.2 microsecond on time, 400 nanosecond off time. Not bad, and good enough for most applications, but you could run into an instance where a customer needs better, and then we'd have to go with one of our other known candidates. As we're learning, some of them are faster. 2080 is super fast, 5511 is super fast, 5020 is fast, 5010 is fast, 5040 is fast, and 4014 is fast. So those are our quickest. $2105. Oh well, you know what? Yes and no. There is a unavoidable. The stability indices go just below 1 at 5 gig. From part to part, sometimes it flirts, sometimes it goes below. There's nothing you can do about it. It's not a problem. Customers will say, "Oh, it's not unconditionally stable," and I just say, "But you know what? If you have it looking into anything decent, you're going to be fine." And most of them are okay with that. It's just not worth going through matching gymnastics to degrade your performance and get unconditional stability. It's just not worth it. There's not going to be a problem. Temperature, it holds out. It holds out. I've run them all over temperature, and I know if there are a few devices, a handful of devices I have concerns with. There's only a few. 2105, 2013, they do fine over frequency or temperature. They do fine. No, except for the fact that it just rounds out our broadband game block family, which we're adding to. We're gonna, the cable amps are coming up. We're gonna have all kinds of broadband solutions. It's getting to the point where I'm losing track. No, it is. It's getting to the point where I'm beginning to lose track, and it's like I'm forgetting. We remembered one this morning. Chris was talking to you about it. The 2505, which is a broadband 4001. And I can match it from 100 to 6 gig. And the only downside is you get gain roll off. That's the only downside. Everything else is flat. P1 dB, IP3, 1 dB noise figure the whole way. And sometimes I forget about it. So it's getting to the point where we're getting so many products, it's hard to keep track of them all. You know? What are you gonna do? What are you gonna do? We're getting too good. Yeah, we got to make more. We're gonna make more.
Thank you so much for watching. If you'd like more information, please email us at sales@gorilla-rf.com. And don't forget to subscribe to our channel for more content from Gorilla RF.